Hello, my name is Marius and today we're talking about how to study maths-related subjects. I, for myself, was a physics student and I'm going to lay out 3 points that I wish I knew before starting studying this subject. Number 1. Find the literature/resources you personally need. Number 2. Focus on studying the theory less than actually practicing. And number 3. Maths is not just maths. Let's get right into it. With number 1. Find literature/study resources that you personally need. I soon have noticed that not all books are actually to my liking. There are many textbooks that exist regarding, for example, physics, but not all of them are good. Some are more theory-based, mathematical, some are more experimental-based, with more pictures. And I really had to do my research to see which one I like most. I probably would have saved a couple hundred years on textbooks if I would have known that there are better ones and worse ones. Of course, there's required literature that I would buy anyways, but there's, most often as well, an online library where you can download the PDF. And regarding an online library, I soon have noticed that my professor is pretty cool, but most often also quite boring. But the thing is, we just have this one professor, don't we? We cannot choose which one is teaching us what. That's fine, because there are online libraries for lectures as well. I mean, you're at YouTube right now, just type in lecture ... for subject ... and it comes up. I want to quickly mention OpenCourseWare from MIT, where you can get full lectures with worksheets for free, and that by MIT. So if you don't want to study with your professor, attend their lectures of course, but go do additional research with the professor that you have personally chosen. Which leads me to point number 2, and that would be practice over theory. Genuinely, I'm a theory kind of lot. I like sitting down there with my textbooks and just going through them, trying to prove a concept, but that doesn't help me with actually doing the exercises. And the thing is, while proving also will be part of your exam, you need to apply what you've learned to a new exercise, which is why at the end of the day, the theory is not as important as practicing it. And a lot of your theory will be studied and will be understood by doing the exercises and not other way around. It's the hard truth, and it's a bit annoying for everyone who really likes studying just the theory. You also by that will be able to draw lines in between concepts. How are things connected to one another? How will topic 1 lead to topic 2? And the thing is, topic 1 is important. You will not get around starting at the foundation. You need to have studied that for good and learned the in and outs of it. And that is most often done by actually practicing it. But maths is not just maths. You will soon notice that our brains can't fully comprehend everything, which is why we need coding. For example, for very complex differential equations, or when you want to visualize something. It's always good to know a couple of programming languages. And throughout your studies, you will come across Python, MATLAB, or /and LaTeX. And those 3 programming languages come in so handy because the amount of formula that you have is overwhelming. You can create beautiful formula sheets that you can just scroll through. But maybe you can't do that from day 1 on. That's why I created a Formulae Collection, which is space for 200 plus formulas. It comes as part of a university starter kit, which you can get in the video description. I want to quickly run you through it because it's quite important to me that you understand the layout and what you can do with it. So after purchasing it, you click on download on the deliverable, where you'll be sent to a Google Drive. There you can view your 10 designs and can choose the one which you like the most. Of course, you own all 10 of them, so can also download all 10 of them. But if you, for example, just like this design, then just download this design to files. Then on files, you can import it to, for example, GoodNotes, Notability, or whichever other PDF reader you have. Like for example also Adobe Acrobat Reader and so on. Here you have an index, a collection of all your important formulas, which are linked to space for proofs, examples, or definitions, that you have an overall collection of your equations. I for myself would, for example, assign one color, like for example green, to experimental physics, blue to theoretical physics, then the simplistic design to mathematics, and so on. And with that have one formula collection per subject. Comes in pretty handy. And that being said, thank you very much for watching. Watch this video up here in case you want to learn about how to take notes efficiently in university so that you can retain more by studying less. See you all next time.